Ravi Prakash, and this is the 7th class of remainders. Okay, so in this we'll discuss about Wilson's remainder theorem. Right, so Wilson's remainder theorem are basically related to factorials. Okay, factorials, right? So for example, see, if I write here, what is remainder of 16 factorial by 17 factorial? What is the remainder? Right, can you tell me? Or what is the remainder if 17 factorial is divided by 16 factorial? Right, so see, in this case, remainder is whole 16 factorial, right? Whole 16 factorial, because when numerator is less than denominator, okay, that means suppose it was 16 by 17, or suppose it was 5 by 10. So what is the remainder when 5 is divided by 10? So when 5 is divided by 10, remainder is 5 only, right? We don't cancel it. We don't cancel 1 by 2. I've discussed this concept, right? We don't cancel. Or if we cancel, we multiply by cancellation factor also. Okay. So 5 by 10, remainder is 5 only. Okay. 5 by 10, remainder is 5 only. That means if numerator is less than denominator, so if numerator is less than denominator, then whole of the numerator is the remainder, right? So here also 16 factorial is less than 17 factorial, right? So whole of the numerator will be remainder, because numerator is less than denominator. Okay, so what is the answer here? 16 factorial, right? Here now 17 factorial by 16 factorial, right? So in this case, denominator completely divides numerator, because suppose what is remainder of 10 by 5? So 10 by 5 remainder is 0, because 5 completely divides 10. Nothing is left as remainder. Nothing is left as remainder, right? So what is the remainder? 0. Here also 16 factorial completely divides 17 factorial. What is the remainder? 0. Right. So small concepts, right? Okay. So what is now Wilson's remainder theorem, right? So Wilson's remainder theorem is related to factorials, right? So let's suppose P is any prime number, that means P minus 1 factorial upon P, remainder is what? Remainder is minus 1. Okay, this is Wilson's remainder theorem. Or P minus 2 factorial upon P, remainder is plus 1, where P is any prime number. P is any prime number, right? So P minus 1 factorial upon P, remainder is minus 1. P minus 2 factorial upon P, remainder is what? Plus 1. Okay, for example, see, if I write here 28 factorial by 29, what is the remainder? So since 29 is a prime number, so it is P. So it is P minus 1. So 28, right? So what is the remainder? Remainder is what? It is minus 1. So minus 1. Or what is the positive remainder? 28, right? 29 minus 1. What is the positive remainder? 28. Okay. Similarly, if I write, what is the remainder? What is the remainder if 21 factorial is divided by 23? What is the remainder? So 21 factorial by 23. Okay. What is the remainder? Remainder is plus 1, because P minus 2 factorial upon P. What is the remainder? Remainder is plus 1. Fine. Okay. Next question. Now see, what is the remainder if 1001 factorial is divided by 1003? What is the remainder here? Right. Now, this question looks like answer is plus 1, but it is wrong. It is wrong, right? Why it is wrong? Because in this case 1003 is not a prime number, right? What is 1003? I have told you 1003 is a multiple of what? 1001 is a multiple of 13, 1003 is a multiple of 17, 1007 is a multiple of 19, 1009 is the first 4-digit prime number. We have discussed this earlier in numbers, basics and factors, right? 1009 is the first 48 prime number. So 1003 is a multiple of 17, right? This is exactly how much? 17 into 59, right? It is 17 into 59. So that means, so if it is not plus 1, then you'll ask me what is the answer, right? If it is not plus 1, right? Because 1003 is not a prime number. It is not a prime number. Is not a prime number. So it is not plus 1 now. It does not follow the Wilson's remainder theorem. So that means what is the answer then? See, 1001 factorial. What is 1003? It is 17 into 59. Right? Now, in 1001 factorial, it is multiplication from 1 to 1, 2, 3 into 4 into 5 into 6 into till 1001. Right? Obviously, somewhere 17 will come. Obviously, somewhere 59 will come. Right? So both will completely cancel. Right? That means denominator completely cancels numerator. What is the remainder? Remainder is nothing but 0. Denominator completely cancels numerator. What is the remainder? 0. Because in 1001 factorial, obviously sometimes 17 will come. Obviously sometimes 59 will come from the multiplication of 1 into 2 into 3 till 1001, right? That means denominator completely cancels numerator, right? What is the remainder? 0. Okay. Now, next one. Okay, we have seen for p minus 1. Okay, that means suppose 36 factorial upon 37. What is the remainder? It is minus 1. Right? P and p minus 1, because 37 is a prime number. So p and p minus 1. Okay. Or I can write what is the positive remainder? Positive remainder is what? 36 here. Okay. So positive remainder is 36 now. Okay. Now, if I write 35, so 35 factorial by 37. Okay. Still we have a positive remainder here, right? Because p and p minus 2. So it is how much? Plus 1. Simply plus 1. Okay. These are two statements of Wilson's remainder theorem. What if now, if I give you a question, what if 34 factorial by 37 remainder, I need to ask 34 factorial by 37, what is the remainder now? Okay. Now see, for this there is no such final answer, right? There is no such proper formula, but we can derive one. See, we'll solve it, this question. See, again, that by reverse, right? The way we discussed that reverse Euler theorem, same. Because I know that if it was 36 factorial here, when the answer was what? Then the answer was minus 1. But here it is 34 factorial, right? So I know that for 36 factorial by 37, what is the remainder? Remainder is minus 1. But I want for 34 factorial, right? So I can write like, okay, 34 factorial into 35 into 36. What is the remainder? Remainder is minus 1. Okay. Now again, if I move, right, what is the remainder here? 35 by 37. What is the remainder? Minus 2. 36 by 37. What is the remainder? Minus 1. Remainder is minus 1. Okay. So what I should write here? Now, it is minus 1, or never forget, it could be what? It could be 36 also, the positive remainder, right? It could be 36 also, or it is minus 1. Fine. So see, see here now 34 factorial by 37. What is the remainder? Now this minus 2 into minus 1 becomes 2. Now 2 will come here in denominator, right? So obviously it can't be minus 1 by 2. Obviously it can't be minus 1 by 2, right? It has to be 36 by 2, because we have to take this number here as per our convenience, because remainders can never be fractions. It has to be, remainders can never be fractions. It has to be integer, right? So minus 1, this minus 2 into minus 1 is 2. So 2 can't be, minus 1 can't be, because what is the remainder? Minus 1 by 2, not possible, right? So I can take here 36. 36 by 2, what is the remainder? 18. Right? This same concept what we discussed here, right? Because this, when remainder is minus 1, see, when it is minus 1, so 34 factorial by 37. What is the remainder now? You can write here that remainder is minus 1. So say, what is the form of remainder? So form of remainder is a number when divided by 37, remainder is minus 1. So form of remainder is what? 37k minus 1. Form of remainder is what? 37k minus 1. Divided by what? This 2 divide by 2. So you have to see for which value of k it is divisible. Because I want a number here, I want a numerator which is divisible by 2. So obviously at k equal to 1, that is 36 by 2, that is 18. Right, so funda is same here, right? Funda is absolutely same. So what is the answer? Therefore, 34 factorial by 37 factorial. What is the answer? Remainder is 18. So 18 is the answer. Fine. Okay. One more we'll do to get the clarity. One more question. See. Suppose I take 20 factorial by 23. What is the remainder, right? What I'm taking here in this type of questions, what I'm taking here, 3 steps back from denominator. 23, so it is 20, 3 steps back. Okay. What is the remainder here? So again, same thing I'll do. I know that for 22 factorial by 23, the remainder would have been what? Minus 1 or 22. So this I can break as 20 factorial. This 22 factorial I can break as 20 factorial into 21 into 22 divided by 23. And then what is the remainder? It is minus 1 or 22. So this is what? This is minus 2. This is what? Minus 1, obviously, right? It becomes 20 factorial by 23. What is the remainder? We can't take minus 1 here, or better you can directly write the form, right? What I can do here is, we can't take minus 1, so we can take 22. So 22 by 2, because minus 2 into minus 1 is 2. 2 will come in denominator. So 22 by 2. What is the answer? Answer is 11. So 11 is the answer, right? Correct. 11 is the answer, right? But what else we can do is, we can also use a form like 20 factorial into 21 into 22 divided by 23 remainder. Okay. What is the form remainder now? A number when divided by 23, remainder is minus 1 or 22. So you can use the form as, okay, 23k minus 1. Or it could also be 23k plus 22. Both is your wish, right? Now this is minus 2, this is minus 1. So 20 factorial by 23. What is the remainder? It is 23k plus 22 or 23k minus 1. It's your wish what you take, what you want to take here. So it's 23k minus 1 by 2. At what value of k it is divisible? At what value of k this denominator is perfectly divisible by 2. So obviously at k equal to 1, right? At k equal to 1. That means 22 by 2. That means 11. That means 11, right? If you would have taken 23k plus 22 instead of 23k minus 1, then it will be divisible at what? K equal to 0 only. But answer would be same. 22 by 2, 11, right? So answer would be same in all the cases, right? Okay, fine. So 2 things to observe from here. First thing is 34 factorial by 37. What is the remainder we got in the last question? Last to last question? 18. Okay. And 20 factorial by 23. What remainder we got? 11. Right, 11. We got 11. Right. Now you can see here. What is 18? 87 is what? 37 minus 1 by 2. What is 11 here? 23 minus 1 by 2. This is a general form, right? This is a general form of remainder. Okay. So if we have like p minus 3 factorial upon p remainder, it will always be what? Denominator minus 1 by 2. That is p minus 1 by 2. That is the answer. Always this is the answer, right? So this you can write as third statement of Wilson's, right? First was p minus 1 factorial upon p, remainder is minus 1. Second is p minus 2 factorial upon p, remainder is plus 1. Third is this one, p minus 3 factorial upon p. What is the remainder? P minus 1 by 2. Okay. Suppose if I have a question like this, what is the remainder if it is 56 factorial by 59? What is the remainder? Okay. So answer is in one step. Answer is in one step, right? What is the answer? 59 minus 1, because 59 is a prime number. 59 minus 1 by 2. What is the answer? 29. So 29 is the answer for this question. Okay, so 29 is the answer for this question, right? I hope it is clear. Okay, fine. We can discuss some good questions here. Okay, Suppose the question is, now going one more step back, like suppose 27 factorial by 31. See, for this, we'll not derive any formula for 4 or 4 or 5 or 1. Okay, we can remember for 1, 2, 3, but we can't remember for every step, right? For one step, 31, this is 27, 4 steps back from 31. Okay, so 1 step back, 2 step back, 3 step back. Okay, there are 3 formula, you can remember it, but don't remember for 4th one, right? What we can do here is instead use the logic, right? So how do you use the logic here? See, now 27 factorial by 31, it is a remainder. Okay, so we can write like this. I know that 30 factorial, I know that 30 factorial by 31, that remainder is what? That remainder is -1, that I know. Okay, that 30 factorial can be written as in terms of 27 factorial. Okay, 27 factorial into 28 into 29 into 30, that's like writing 4 steps, right? So right now I know that what is the nearest number to 27. So it should be like 27 into 28 into 29 into 30. Okay, fine, no issue. Divided by 31. But why to do this 4 steps? Why? Because we already have the answer for 28 factorial, right? We already have the answer for 28 factorial. So I won't write 30 factorial. Instead, what I'll write? I'll write here 28 factorial, right? The shortest. So I know that what is if 20, the nearest to 27 factorial. What I know is I know for 3 steps back, right? If it is 28 factorial, then what is the answer? P minus 1 by 2. Right? We just discussed this. P minus 3 factorial upon P. What is the remainder? It is P minus 1 by 2. Right? It is P minus 1 by 2. What is the remainder here? 31 minus 1 by 2. That is 15. So answer here is 15. Right? So for 28 factorial, what is the answer? Answer is 15. Right? So do like this. No issue. Okay. That means now 20. With this we have to write in terms of what? 27 factorial. No issue. 27 factorial into 28. 28 factorial can be written by 27 factorial into 28, right? Divided by 31 remainder. That is 15. Or now what you can write? Because 31, 28 by 31. What is the remainder? -3. Right. So again, what remainder I want? I can write the form here, but I can observe that 15 is already divisible by 3. So we don't need to write that form. What is the form? That form will be how much? A number when divided by 31, remainder is 15. So 31k plus 15 is the form. Okay. But it is not required because 15 is already a multiple of 3. Right? So it is 15 will already divide 3. So not an issue here, right? So not an issue. So absolutely not required. So what I can do? 27 factorial by 31 remainder is required upon 15 by -3. So what it will be? It will be -5, right? It will be -5. So it becomes -5. So 3 answers -5, right? So what is the answer? -5. So therefore 27 factorial by 31. What is the remainder? -5. So what does -5 means? -5 means it is a negative remainder. So add to base with sign. So 31 minus 5. What is the answer? Answer is 26. So 26 is the answer for this question. Okay, very good question. Very good question. Okay, very good question. Right? Now, one more same variety we'll discuss. Once more, same variety we'll discuss. Okay. Question is 17 factorial upon 23. What is the remainder? 17 factorial by 23. What is the remainder? Now, 17 factorial by 23, right? Again, what nearest I know? 23. The nearest I know is 20 factorial by 23. What is the remainder? P minus 1 by 2. 23 minus 1 by 2. That is 12. Sorry, 11. So 11. So I know that 20 factorial by 23 remainder is 11. This is the nearest I know. I can connect with 17 factorial now. Okay. So this 20 factorial can be written like 17 factorial into 18 into 19 into 20 divided by 23. And what is the remainder here? Remainder is 11. Okay. So this is how much? So divide individually. So 18 by 23. What is the remainder? -5. 19 by 23 minus 4. 20 by 23 minus 3. It becomes how much? It becomes minus 60, right? It becomes minus 60. So again it is like, okay, I should again write like, it becomes 17 factorial into minus 60 divided by 23 remainder. That is again 11. Now 23 into 2 is 46. So what is minus 60? So minus 60 is what? Minus 60 becomes, what is the remainder here? So 17 fact 23 into 2 is 46. Into 3 is 69. So what is the positive remainder here? So we can write like, we can cancel here. 23 into 2 is 14. So what is minus 14? So minus 14 is left. So minus 14 basically means what? 9. Because what is the divisor? 23. So negative remainder is minus 14. So what is the positive remainder? Sorry. Negative remainder is minus 14. So what is the positive remainder? Positive remainder is 9. Okay. Positive remainder is what? 9. So I can directly write here. Okay. I can directly write here. Okay. 17 factorial into 9 divided by 23 remainder. And here it is 11. Now 9 will obviously come here, but 11 is not a multiple of 9. So that means I need to write here that form of the remainder. What is the form of the remainder? So form of the remainder is what? A number when divided by 23, remainder is 11. So number form is what? 23k plus 11. So numbers for remainder form is what? 23k plus 11. Okay, 23k plus 11. That basically means that 17 factorial by 23. What is the remainder? 23k plus 11 divided by 9. Now this numerator should be perfectly divisible by 9. At what value of k? At what value of k? Should be perfectly divisible by 9 at what value of k? Right. So at what value of k can we get it? First thing is what? Simply put, or what you can do is your wish, right? So either simply put or you can directly do here that 23k plus 11 needs to be divisible by 9. That what is the remainder? The remainder should be 0. Okay, it is 5 here and it is 2 here. That means 5k plus 2 divided by 9. The remainder should be 0. So at what value of k? So obviously at k equal to, you can observe here at k equal to 5. So at k equal to 5. Okay. So I can observe at k equal to 5. 27 by 9, remainder is 0. So that means at k equal to 5. So what is the number here? 126 by 9. What is the answer? Answer is 14. Therefore 14 is the answer for this. Again, super duper question. A beautiful question. Super application of concept of remainders. Okay. 17 factorial by 23. What is the remainder? Answer is 14. Answer is 14. Okay. So again, a very nice question. Yeah, I hope it is clear, right? Okay. Now, just for your more clarity, right? I'll again solve this question taking one more way. Okay, just observe it, right? Answer is 14, correct, no issue. Okay, but one more way, because I've taken with 20, I can take with 22 also. Lots of students will get this doubt, right? Why 20? I can take 22 also. Okay, so again I'll solve this question once more for you. 17 factorial by 23, remainder I want, and I know that 22 factorial by 23, what is the remainder? Remainder is minus 1. Okay, how to connect now? So guys, 22 factorial can be written like 17 factorial into 18 into 19 into 20 into 21 into 22 divided by 23 remainder. Okay, divided by 23 remainder. Okay, now 22 by 23, what is the remainder? Minus 1. 21 by 23, minus 2. 20 by 23, minus 3. Here, minus 4. Here, minus 5. What is the number here? 20 into 3, 16 into 120. It is 120, right? It is 120. Okay, that means it is like, and what is the remainder here? Minus 1. So remainder is minus 1 or 22. Minus 1 or 22. Okay. So now you got 17 factorial into minus 120 by 23. Okay, 17 factorial into minus 120 by 23. What is the remainder? This part you want. Okay, so 23 into 5 is 115. 23 into 5 is 115. So minus 5 is left here. Minus 5 is left here. And what is the right side? Since neither minus 1 nor 22 is divisible by 5, so what you can write? We can write the general form of remainder. What is the general form of remainder here? A number when divided by 23, remainder is minus 1. So you can write 23k minus 1. Okay. So it's now simply like, okay, 17 factorial by 23 remainder. Right? 23k minus 1 divided by minus 5. So at what value of k it is divisible by 5? Now simple question is, at what value of k it is divisible by 5? Okay, and this will be your answer. This will be your answer always, right? So at what value of k it is divisible by 5? Can you observe it? Again, same thing we'll do. Okay, 23k minus 1 is to be divisible by 5. Okay, so here you get 3k, you get 3k minus 1 divided by 5. What is the remainder? Remainder is 0. Divisible means remainder is 0. At what value of 3? At k equal to 2. Right, directly at k equal to 2. So you find, okay, at k equal to 2. So what is the number you put here? That number becomes what? If you put k2 here, 45 by minus 5, it is minus 9. 45 by minus 23 into 2 is what? 46 minus 1. 45 by minus 5, it is minus 9. If it is minus 9, what is the final remainder? 23 minus 9, that is 14. So 14 is the answer. That's what we got in last video also, right? Just to give you more clarity about this concept, it's a tough concept, right? We are discussing very advanced level concepts of remainders here. Okay, so this is the 14 is the answer. Okay, thank you. We'll see the more questions in next video. Yeah.